at how to balance a redox reaction. Okay, so this is the area that students find difficult, especially in exams. Okay, so today we'll be learning how to balance a redox reaction using the ion-electron method. Now, you know, a redox reaction is not like your chemical reactions where you just balance only the atoms, right? In a redox reaction, we are not just only balancing the atoms, we are balancing the charges, right? The charges are also considered. Let me show you what I mean by charges. Now, if this is a normal equation, you can only be interested in balancing the atoms, right? Let's say manganese is 1, you balance 1 here. Oxygen is 4, you look for oxygen here, but there's no oxygen here in the first place. So iron is 1 and iron is just 1 here, okay? So it's not just only the atoms we are balancing in a redox reaction. If you look at the charges, the charge here is -1, the charge here is +2. -1 plus 2, total charge here is +1. But total charge is +5. So you know that the charges are not even the same. So in a redox reaction, we don't balance just the atoms, right? We balance both the atoms and the charges. I believe that you all know what we mean by, if we say chemical reactions. Yes, a redox reaction is a chemical reaction, but the equation is not the same thing with a chemical equation, okay? A redox equation or an ionic equation is different from a chemical reaction or chemical equation, right? Good. Just like the same thing with what? Nuclear equation. So the way we balance a nuclear equation and a chemical equation and a redox reaction is not the same thing. So today we are going to use examples, like 2 or 3 examples, to show you how you can balance a redox reaction so that everything will balance, both the atoms and the charges will be complete. Now look at this question. How do we balance this reaction first? Now, first of all, you must ask yourself which one is the oxidation half. You are going to break this equation into 2 halves, oxidation half and reduction half. Okay? So how do we find out the oxidation half? Look at manganese oxide. Manganese oxide all of a sudden lost oxygen to become manganese. What do you think it is? Reduction, right? Removal of oxygen to become this is what? Reduction. Remember the definition for oxidation and reduction. Removal of oxygen from something, and addition of hydrogen is what? Reduction. But addition of oxygen and removal of hydrogen is what? Oxidation. So for this case, oxygen was removed from this guy. So because oxygen was removed to get this guy, then it means that this and this are undergoing what? Reduction. So I will write this way: MnO4 minus undergoing to this is what? Reduction. This is the reduction half. This is the reduction half, right? So ion 2 became ion 3. 2 electrons, this one, the charge is 2 plus. It became 3 plus, meaning that this guy lost extra 1 electrons to become what? Ion 3. Remember, loss of electron is what? Oxidation. So we have that this to give us 3 plus is what? Oxidation half. So the first step in every redox reaction is to identify the reduction half and the what? Oxidation half. Then the work starts. What is the work? Balance each of the halves, right? Balance each of the halves. But before I proceed to balance, every redox reaction most times takes place in a medium, either acidic medium or alkaline medium. So for this one we are doing here is an acidic medium. What is meant by acidic medium is that this reaction was catalyzed in the presence of an acid, okay? This KMnO4, for us to ionize this KMnO4 into this manganese ion, we have to what? Acidify it. So this is a product of an acidified potassium permanganate. This ion here is a product of an acidified potassium permanganate, right? So the next step is to balance the half, right? Now let's start with the first half. Look at this, look at this. They are not the same. Okay? There's oxygen here, there's no oxygen here. So how do we impute oxygen inside this side to balance this guy? That is where H2O comes in. Anytime you want to balance oxygen, where there is no oxygen, impute water inside that place. Look what I'm going to do. What I'm doing is simple. MnO4 minus. Put your arrow back. Repeat this thing. Mn2 plus you put water. But if I put only 1 molecule of water, It will not balance this 4 because this is just 1 here. So I'm going to impute 4 here. 4 moles or 4 molecules of water will balance this 4 oxygen. But remember now, in the process of putting 4 H2O to balance the oxygen, you have increased hydrogen here to what? 8. That is 4 times 2, 8. So you have to balance it here. So how do you do that? You write MnO4 minus plus 8. You balance the hydrogen with what? A hydrogen ion. Why? Because the medium is what? Acidic. So you use hydrogen ion to balance it. So you now put your arrow and repeat back the same thing here. Mn2 plus 4H2O. It's making sense, right? Yes. So now it means that I have balanced the atoms. 4 oxygen, 4 oxygen. 8 hydrogen, 8 hydrogen. Balance. Manganese is 1, manganese is 1. So what's the next thing? The charges. The charges are not the same. Watch. Total charge. Total charge here is minus 1. Total charge here is 8 times plus 1, which is plus 8. 8 times plus 1. If you want to get total charge, use the coefficient you have here and multiply the charge you are seeing there. So 8 times plus 1 is still 8. So 8 minus 1 is 7. Total charge here. Total charge in this reactant side. Total charge here is plus 7. Okay? But now, look at this side. Total charge in this compound is plus 2. Total charge here is 0 because there is no charge here in the water. So 4 times 0 is 0. So total charge in this product side is equal to plus 2. Now, plus 7 and plus 2, are they the same thing? No. So you have to balance it. So how do you balance it? You bring in the concept of what? Loss or gain of electron. Now remember that plus 7, if a charge is plus 7, and I want to make it equal to this one. Class, if I want to make this thing equal, instead I make this one to go down by 5 to become 2, or increase this one by 5 to become 7. So I need 5 electrons. I need 5 electrons to balance this guy to make it either 7 or bring it down to become 2. So how do I inculcate these 5 electrons? Remember that if you lose 5 electrons, your charge is increasing by 5. Let's know, if you lose or remove 5 electrons from somebody, the person's charge is increasing by 5. That is, if the person has a 2 plus charge and you remove 5 electrons, the person's charge will increase to 7. But if somebody has a charge of plus 7 and you add, I didn't remove, you add 5 electrons to the person's charge will go down by 5. So the person from 7 to 4 down to 2. So watch now, this guy is plus 2, this plus 7. If I want to increase this guy to plus 7, I will remove 5 electrons from this side. If I want to increase this one to plus 7, which is this, I will remove 5 electrons from here. But if I want to bring this one down to 2, I will add 5 electrons to this guy. What I mean is this. If I want to bring this one down by 5 to become 2, the same guy here, I will simply have MnO4 minus plus 8H plus, I will put plus 5 electron. The moment I put plus 5 electron, it means that this plus 7 is going down by 5. It becomes 2, which is balanced with the other one there. So I will repeat the other one there. I'll have Mn2 plus 4H2O. So what it means is that I have balanced this one, just this half. Remember, we're not done though. We just balanced one of the half, the reduction half. So the next step is to balance the oxidation half. Once you balance these two halves now, you can now combine them together and get the overall equation, which is the final answer. So how do I balance this one? Now look at this one. This one is just very simple to balance. The atoms are already balanced. It's just to balance the charge, right? I have Fe2 plus to give you Fe3 plus. Watch. This one 2 plus, this one 3 plus. If I want to balance this thing, it's either I bring this one down by 1 to become 2 2, or increase one by what? 1 to become 3 3. How do I bring 3 plus down by 1? Is by what? Adding electron. Adding electron. Adding. Remember, here was 7. I added 5. It's brought down. So to reduce this one from 3 to 2, I will have to just put plus what? Electron here. I have balanced it. Okay? So the next step now is I will now combine these two halves. I will combine them together. How will I combine them? The only time you can combine these two things is when these electrons and these are the same. They will cancel out. So how can I make this and this the same? I will look for a number that I will multiply everything here with, and then another I will multiply everything here with. If I do the multiplication, I will get 5 electron, 5, so they can cancel out. That number is what? I will use 1 for the first one, use 5 for the second one. If I multiply everything here by 1, if I multiply everything here by 1, nothing will change. I will still have MnO4 minus plus 8H plus 5 electron to give you Mn2 plus 4H2O. Right? If I multiply this second one by 5, I'll have 5Fe2 plus. The number you are multiplying them is multiplying the coefficients. So I'll have 5Fe2 plus give us 5Fe3 plus 5 electron. Okay? So that I can cancel out. This cancels this. And you bring down every other thing before the arrow down. After the arrow, you bring every other thing down. That is the answer. So what I'll have here becomes MnO4 minus plus 8H plus this one now 5Fe2 plus arrow, then repeat the other one Mn2 plus F4H2O plus 5Fe3 plus. So from this now you will notice that at the end of the day you see that the equation is balanced. Okay? So watch. So if you bring down before the arrow, remember I brought down this down, then put the arrow, brought down this down. Now when you are done with your balancing, you check if the final product everything is okay. Let's confirm if it is okay. Manganese is 1, balance. Oxygen is 4 here, balance. Okay? Hydrogen is 8, 4 times 2 is 8, balance. Iron is 5 iron is here, balance. Check the charge. Total charge in the from here to here, total charge is -1 plus 8, which is 7. 5 times 2 is 10. 10 plus 7 is what? 17. This side is balanced, is 17. Let's confirm if here is 17. If here is 17, it's balanced. So here I have 2 plus 5 times 3 is what? 15. 15 plus 2 is what? 17. There is no charge for this guy. So total charge in this right hand side is what? 17. 17 balanced. So it means that the equation has been balanced. So this is how we balance a redox reaction using the ion-electron method. There are other methods called oxidation number methods, but this method is much more better than the rest. It's more efficient. You can see a lot of things happening here. You can understand it properly using this method.